Okay. So SQL and SQL injections. Frank had introduced us to this on Friday. We're going to take a second look at SQL and SQL injections again today. And let's take a look. So first thing I want us all to be familiar with is what SQL looks like and how to think of SQL databases. And so here's our example database. And databases are split up into tables. And the tables, quite frankly, just look like Excel spreadsheets. And if you're with me so far, you're like, have a fairly good understanding of databases then. So you see here in our example school database, I'll call it school, it has two tables. It has students and addresses. You know, there are whole classes you can take on database management and structuring databases as to like when it makes sense to split out tables, right? Because you could imagine a student's table that just has addresses in one of the columns, right? We're not so interested in talking about how to make databases super efficient or the best way of storing our data. I just want you all to have an understanding of what the common ways database storage looks like. So on the students table and the addresses table, you see that there is a link between them on the address column of students, right? The other thing I want to bring to your attention is both tables have unique identifiers. We call them primary keys. That means on any table, there can only be one entry that has that unique identifier. In this case, those identifiers are just numbered 1, 2, 3, 4, 5, you know, increment by 1 every time. Some databases have it set up that it's slightly more like random, but either way, there's some unique identifier for every entry on a table. So those unique identifiers, we call them primary keys. So if you see Nick D has the unique identifier 1, Andy D has the unique identifier 2. If we look on addresses, you know, 423 Main Street, unique ID 1. Same idea here. Now, if you look at the students table, you'll notice there is another key. We call it a foreign key. So if you look at Nick D and Andy D, they both have a foreign key under address of 2. That means if you go to the address table and look under entry 2, that is all the information there. So Nick and Andy live at 13 Main Street in Barrington, Illinois. Okay. Beth, if you look under her address, she has the foreign key of 1. So I just means I go to the address table, I look under ID 1, that means Beth must live in 423 Main Street. Okay. So the big things I want us to take away from this is SQL databases have tables. Each of the tables have unique identifiers called primary keys. And we can link data together based on their foreign key to another table. Questions so far on this terminology? This is just ways we can store information. One thing I do want you to keep in mind is the way we store information is not necessarily the way we're going to use that information, right? So this is just one way of storing the information of students and their addresses. Put them on 2 separate tables and relate them with a foreign key, okay? So there's a language called SQL, structured query language, for essentially writing and reading to the database. And we're going to go through some of the syntax of it. It's a whole nother language that you're going to learn. One thing I want to tell you is it's a bit different from all the other languages. It's not like Python or something. It's what's called a declarative language. You kind of just declare what you want and then you get it. Kind of like CSS. So like CSS, you could say, hey, all that text is blue, right? That's all you have to say, and then it'll be blue. Same idea here. In SQL, you just select what you want, and then you'll get it, which sounds a lot easier than it is, but the syntax is all the same. First, even though it's not written in this way, you choose what you want to get your data from. Essentially, you're picking a table. Then you have to pick which columns you want from that table. So if I wanted and then finally, you have to choose some sort of filter. You don't have to choose a filter, but usually we want filters when we're pulling data from a database. So there's 3 words there: select, from, and where. From is going to be which table you're taking data from. Select is which columns you want. And where is so you can filter the rows based on column data. So in this case, if I wanted to write a SQL query to grab all students that had the age of 20, I would write select name, age, gender from students where age equals 20.
Yeah, are the slides changing? Because
they are not changing. You are looking at that same table.
Okay.
Right? Same table. So exactly what I said, that's how you would pull out all 20-year-old students. Select what columns you want. So here we're pulling out the ID, the name, and the age. From what table you want, from the students table, and then some clause that we'll use to limit it, where the age is equal to 20. Okay. Syntax is pretty readable. But yeah, that's what SQL will look like. What table you want to pull from, what columns you want, and then some sort of filter. And this would be the result of that query. You get another table, like a virtual table, you can think. Okay, it's a smaller one now, but this is what the result of that query would be. Select ID, name, age from students where age equals 20. It does that. Cool? Cool. So here is our students and addresses table, right? Just lined up like that. All students with their addresses. We have foreign keys that match. So Nick D and Andy D both have address number 2, right? That is a foreign key on the address table. So we go to the address table and look at 2. They both live at 13 Main Street. Nick D and Andy D, I would guess, are probably siblings. They live in the same place. Okay. If I wanted to combine both of these tables, so I had students with addresses, I have another keyword. Does anyone know what the keyword is to bring 2 tables together?
Combine?
Join. To join these 2 tables together, we use the join keyword. And in order to use join, you have to specifically say what you want to join on. So in this case, we want to join that the student's address is equal to the address ID. Does that make sense? You want to join wherever you see the student address, just like take all that information there and grab it from the address table, that ID. Okay, kind of makes sense. So let's see how you would write that in SQL. So you would select the students.id, that's the ID from the students table, right? I have to be specific now because everything has an ID. And I choose the name, the street, the zip, and the city, right? Give me all of the columns that I'm looking for. From the students table. Now here's where I have to join. I'm joining the addresses table. And what am I joining it on? Students.addresses equals addresses.id. Now it's not super important that you guys all memorize the syntax and how to do your SQL joins. But it's important to understand what this looks like and how kind of SQL is formatted and how these relationships are. Okay. But the end result is I get a new table, students with addresses table, from writing that query. Okay. Cool. I can tack on another clause there if I want to, right? If I only want students that are from Chicago, I can add a where clause and filter down at the end. Important to note, there's all different types of syntax I can use so that it's like, case sensitive or not case sensitive and stuff like that. We can look those things up as you're writing SQL. Okay, so here are the important SQL keywords I want you to be familiar with. I don't need you to become SQL DB admins. I just need you to understand what SQL looks like as a language and how queries are formatted. These are the important keywords that I want you to be familiar with for querying SQL. Right? Select which columns you want, from which table we're pulling data from, join when you want to combine two tables, on what specific part of the table you're combining them on, and where to filter. There are more keywords, but these are the important ones I want you guys to be familiar with. Okay. I want to show you this tool or this cheat sheet again, now that we have some more context on how this works. Actually, I'd like to come back to this. I want to show you what SQL injection looks like before I show you some common payloads. Okay, so first definition, we have many different kinds of data stores, right? SQL is just one of them. We have different kinds of databases. I showed you way back when in the earlier slides of today, different databases that can be used, right? There's SQL, MySQL, MongoDB, all kinds of different things, Redis. Right? This is just one particular type of them. Most web apps are going to have some kind of database, right? If you need to store data, you can use a database. Okay. Where is this going? So this is, I want to actually show you the next slide. Apologize that this one is a little bit blurry. I have it clearer on the next slide, so don't hurt your eyes too much. Actually, let's just go right to the next slide because it has both of them. There we go. That's both of them. Okay, so at the top, I want to show you what's happening here. When you use a web app, you only get to talk to the web server. You don't get to talk to the database. The web server is like Mama Grizzly or something. You can't talk to its database baby. You're not allowed to. You can only talk to web server. You make a web request to talk to the web server. So if you look at the top there, http://webshop.com/user.php, and then you see question mark user ID equals 1. Right? That's some parameter where it probably looks like I'm looking for some information that has information about user ID number 1. Right? So I make that request. The web server, well, the web server doesn't know anything about that, so he has to go ask the database server. Right? That's where we store everything. So in order to speak to the database server, he's going to write SQL. And the web server says select star, which gives me everything from the user table where user ID equals 1. Okay, the database makes that query, right? Gives back the data to the web server. The web server takes that data and maybe puts it into some HTML and then sends the HTML as the web response to the client. This is how it normally works. This is what normal interaction looks like, right? You make a web request to the web server. The web server might have to talk to a database based on that web request. The database sends some information to the web server. The web server sends the response back to you. Okay, so what does the SQL injection attack look like? I want you to put your attention onto the SQL injection attack in red at the top left, where it's webshop/user.php question mark user ID equals 0 or 1 equals 1. I have changed this request a little bit now, right? It's not just user ID equals 1, it's user ID equals 0 or 1 equals 1. The server is going to take that information right in there. It's going to grab that, and it's just going to plug it into the SQL statement, right? Because that's how it normally works. It's just going to normally take a user ID, and then so give me that information from the user ID. And the web server does what it's supposed to and just plugs it in there and gives it to the SQL query. And SQL interprets this, and it says, okay, select star from the user tables, grab everything from the user tables, all right? And then we're going to filter where the ID equals 0. Well, no one's ID equals 0, or 1 equals 1. Well, 1 equals 1 for everybody, so I'm going to give you everybody then, right? And so the database is just doing what it's supposed to do, and it gives everybody to the web server, and the web server gives everybody to the attacker. This was a poorly formatted SQL query that the web server did not fix. Very similar to what we were doing before, where we were like trying to get the command execution by formatting it in such a way that and then we put our payload there. Very similar idea of what's happening here. We're tricking the web server to run SQL that we want. Okay, cool. Okay, so let's talk about the impact of SQL injection. So the big idea here is anyone can then read from the table. But there's more things you might be able to do too. You might be able to update, add, delete, any kind of things with the database. So think of what are some potentially harmful effects that would follow if such a database was controlled by an attacker. What could we do?
Put yourself on a table, give yourself root access.
Maybe not necessarily like root access, right? So this database is for a web app, so it'll probably have users on there, and it'll probably have an admin panel, right? Most web apps have some panel for people that administer the user, administer the app to have a admin panel, right? Just like LearnDot in FullStack's LearnDot has an admin panel. That's how I can manage different cohorts. So one thing you might be able to do is add yourself as a user on the admin table. Or if they, depending on how they structure it, maybe it's just a flag on the user table. Is admin true? Change it to true or false, right? All sorts of stuff I can do here, right? If I run the database, I can get all sorts of information, right? If people reuse passwords, all types of stuff I can grab. So how do we stop against it? Right, that's the important part for us eventually. So they're easy to avoid, if I'm being honest with you, right? These vulnerabilities is someone screwed up. Someone left the gate open. Someone didn't update some update. Most of the time we'll find these when you as a user can make dynamic queries, right? I'll show you an example of one of those coming up. But essentially any kind of form where I can search for stuff, very likely that has to go to the web server. The web server has to make some kind of SQL query to a database and get the information for me, right? So if that means it's got to do a query based on what I say, then it's a dynamic query. So then hopefully I can format it in such a way that it gives me more information than it should, kind of like Fonzie, hitting the jukebox. Right, so here's how we stop against it. Here's how the blue teamers stop against us. So they use prepared statements with parameterized queries. That means only specific queries can be run or stored procedures. They do what's called validating untrusted data or sanitizing inputs. That means they'll take your query and they'll say, well, I'm sorry, you can't search for equals. We're just not letting you you're just not allowed to search for equals. You're not allowed to search for quotes inside your string either. All right, we're going to pull all those things out. Other things we could do after the fact is encrypting the sensitive data and securing passwords by hashing them. So even if someone does get access to the passwords, they only have the hashed and hopefully salted passwords. Cool. So let's give an example of some SQL attacks right now. Cool. We'll close this. And very nicely, we have a SQL injection test or vulnerable part of the web app. I like to just show you guys first how this works, right? You can put in a user ID. If I put in 1, it goes and queries the database, right? And it gives me the information for that user ID. So ID 1, first name, surname. I could search 2, right? I have some people in this database already. I think there's 5 people in it. I do 6, oops, come back up here. I do 6, I don't think there's anyone for 6. Cool. So there's 5 people in my database. Let's look at what this code is that's actually running. This is the server code. We have to find where is it that I actually get to write anything. So we could look through the actual request itself, but I'm going to look through the server code. And it's saying if it's a submit request, and it looks like this is the actual data that it pulls from for me. This ID grabs this and saves it as the ID variable. And then what does it do? It makes some new variable called getID, which is equal to this string, select first name, last name, from users where the user ID equals this, right? This part right here, this ID, that's where I'm allowed to write. That's my little hole. That's where I can place my payload. Okay. Now my job is to change this statement, right? So that we'll have like where user ID equals like 0 and do like one of those or 0 equals 0 things. So that'll give me everybody, right? Does that make sense? This is the only place I actually can write any code because this is what what the server grabs. Then what does it do with it? We can read the rest of it. Has some variable called result, which seems like it gets send this string into MySQL query. So this must be a function that actually runs the query. And then what is it going to do? If there's an error, it'll show it to you. And then it looks like it makes that little table for you. So you see that ID, the ID, first name, the first name, surname, the last name. So just again, so we see what that looks like. I'm just going to put 2. That's this. Okay. And this is where I can change the code. Okay. So we can change this. I want to do it with some kind of, I was looking for something that can do some more syntax highlighting to make it more clear. But I don't think I found a good one. But we can put in something like, oh, this is always good to show you. If I put in a quote, what's going to happen? Well, let's find out. Server breaks. And then it even tells me the error. It says some error in your SQL syntax. Check your manual. That corresponds to MySQL. Says even what the error is. I have like an extra quote somewhere. So let's look at the code. What's happening here? Right? It's where ID equals this. It's like, but there's an extra quote in here, and it's throwing the whole thing off. So let's actually get it to work. If I put 0 quote, and then, or I think 0 equals, and then 0. If I copy that, let me see if I have a text editor here. That's what I want. Copy that there. Let's grab this whole thing. Here. And then this is what I'm going to change. Put this in for ID. So it should look like that. I apologize if this is not large enough, but I'm going to copy and paste it into Slack so you can all see. Just so you can see my payload there. Cool. So if I run this, now you can see I'm getting the entire table. Right? ID 0 or 0 equals 0. Right? 0 equals 0 for everybody. Okay. There's more stuff you can do here. The other thing I would like to add is you'll sometimes see what's called SQL blind injection. In regular SQL injection, very, very handy, it was giving us the error and telling us what was going wrong. You can actually do SQL injection without getting anything back. It's called blind SQL injection. It's a bit more challenging, but you'll use techniques like, if this case, tell the server to wait a few seconds and then send me the response. And then based on how long it takes, you get your answer, sort of thing. So it's really kind of playing around with it. Okay. You have any questions on SQL injection?
Matt, what are you doing when you you put your, I saw the 0 equals 0 in the text editor. how are you getting it into the code on this site? I didn't see where you did that.
Oh, all I did was paste that here. Oh, let me grab the whole thing. Here's my text editor. This was the payload I wanted. So this, Control C. I literally just pasted it here and hit submit. And so if we're following what happens, this makes a request, right? I'm assuming a post request. You can check out what it actually is, but it makes some request. This code gets that, receives it, grabs the ID parameter from the request, which was whatever I filled into that form, and then runs this code. Oops, this is not the actual one. Where is it? This code. And this code has to run a SQL query where it's running it based on stuff that the user gave us, right? And this is like a common behavior. Like imagine you go to like IMDb and you want to find like every movie that had like Matthew McConaughey in it, right? That's a dynamic query. And it should be allowed, right? This is something that we should allow users to be able to do. The problem is, someone with malicious intent can change this query in such a way if we're not careful and make it so that it's still a valid SQL query, but we've tricked the web server. Okay, cool. Cool. So that's the countermeasures and that's SQL injection. All right. I think that's all I have for now.